Okay, folks, math group time. So, today I'm going to teach you a little bit about finding factors of larger numbers. You've played the Factor Captor game, many of you have, and you remember that. And there is a system, a methodical, step-by-step system that you can use to find factors of even bigger numbers. All right? So let's give this a try. First, we've got to find factors of the number 100. And I'm certain that you can start to think of those already. But in order to keep on our methodical system method, we're going to start from the beginning. Here's how it looks. Think of number 1 times something will give us 100. 1 times something. Well, we know when 1 times any number is that number. So if 1 times 100 gives us 100, we know that these two factors are, in fact, factors of 100. So I'm going to list those over here. Our smallest factor is 1. Our biggest factor is going to be 100. Okay. So from there, let's move on. Let's think about a larger number. Let's think about the number 2. 100 equals 2 times something. Well, the number 2 will always go into an even number. Any even number is always divisible by 2. So we always just look to the ones place. And if the ones place in any number has either a 0 or a 2 or a 4 or a 6 or an 8, we know that it's an even number. So, in fact, 100 is even. There's my sock. Clean sock. All right, so 2 is definitely going into 100. And we could count by 2s. It would take us forever. We could do it. We could think in our heads, well, 2 times what gives us 100? We could also, if we always are unsure, we need to show it with division. Because we know the division is a fact family with multiplying. So when we're thinking about factors, we're often thinking about dividing. All right, so 100 divided by 2. Well, 2 doesn't go into 1, it goes into 10, 5 times. 2 times 5 is 10. There are 0 left over, but we have to bring down that extra 0. And then we have to show that division step. 2 divided by 0, or excuse me, 0 divided by 2 is 0. So it goes in evenly, perfectly, and our other factor is 50. 2 times 50 is 100. I'm sure that you were thinking that already. Let's keep moving up. We'll try 3. So 100 equals 3 times something. Well, let's always move to that method of long division to help us. We know that 3 can go into 100, but will it go evenly? That's the question. So 3 does go into 10 3 times, and we've got 9 with 1 left over, and we've got 10. So 3 into 10 another 3 times, 9 and 1 left over. That is our actual remainder. And because there is a remainder, it's not a factor because it doesn't go in perfectly even. So we can remove 3 from our potential list. Let's try 4. All right. Does 100 go into 4? Well, we know that 100, or at least the first 2 digits here, 4 does go into 10 twice. And that is 4 times 2 is 8, and we've got 2 left over. Does 4 go into 20? You know your math facts. You know 4 times 5 is 20 perfectly, so there's going to be no remainders there because 5 times 4 is 20. 20 take away 20 itself is 0. 25. Very good. The next factor is 4. We're skipping 3. And here we've got 25. All right. Sock puppet's back. Let's erase that. Let's try 100 is equal to, let's move up, 5. Well, you can count by 5s. That would take a little bit of time. It would certainly work. 5 is always divisible by large even numbers, 10s, and any number that has a 5 in between in the ones place. So we know that 5 does go into this group of 10 right here, exactly twice. That's left over 0. 5 into 0 itself is 0, so 5 times 20. There's an interesting relationship here. It's kind of cool. We can see that 5 is 1 more than 4, right? And 20 is exactly 1 group of 5 less than 25. 20 is exactly 5 less than 25. And 5 is exactly 1 more than 4. Interesting relationship there. All right, we're going to move on. We're going to start back to the green again. Okay. Get rid of these little guys. So is 100 divisible by 6? Well, I'm going to start showing over here. 6 into 100. We know 6 is going to 10. There's 4 left. 6 into 40. Well, 6 times 6 is 36. And 6 times 7, 42. That's too high. And that's too low. So 6 is not a factor. We can move on from that. Okay. How about 7? 7 is always a weird number to work with, but no matter what, you can certainly use it with our method of division. Now we do know that 7 does go into 10 here once, with 3 left over. And if our times tables serve us right, 7 times 4 is 28. 7 times 5 is 35. That's too high, and that's too low. 7 is not a factor. Ooh, we're getting close to the end here, folks. Let's try 8. 8 into 100. Once, 2. No, because 8 goes into 20 only twice for 16, and there's 4 remaining. Because there's 4 remaining, not going to work. 8 doesn't work either. Let's try 9. Well, if you know your times tables, 9 times 10 is 90. 9 times 11 is 99. So then 9 times 12 is going to be bigger. Yeah. 12 times 9 is in fact 108. So that's not going to work either. And I could have certainly done my long division method. It works every time. Just wanted to show you these 2 ways instead. Yeah. 11 remainder 1. Yeah. There's that 99 plus 1. Okay, not going to work. How about 10? 10 times something. Well, we certainly know our 10 times table is 10 times 10, so that will work. And there you have it. Here are our factors of 100. We've got 1, 2, 4, 5, 10, 20, 25, 50, and 100 itself. And there you have it. So I'd like you to try one on your own. I want you to try to find all the factors, not of 100 this time, but of 120. All right? I want you to use The same method. 120 is equal to something times something. You can start with 1, always the best spot, and then move on up after that. Okay? So take some time now to work that out with a pencil and paper. And when you've come up with an answer, I'm going to share with you another video that shows exactly the correct answer for this. And you can compare your work to what is shown on that video. It's a video by a man named Sal Khan. He's a great mathematician. He's been around for many years. And he describes it a lot like I do. And he uses colors too. It's awesome. So work this out first for yourself. Create your list of factors over here, starting with smallest and biggest on the far ends, and then fill in the missing factors inside after you've shown all of your steps and your division and so on and so forth here, okay? All right, so happy factoring.